have note cards here. I forgot my note cards today, but you have note cards that you can choose an answer. But I'm going to actually announce the answers, and then I'm going to have a show of hands of which one you think it is. So I thought it'd be nice to come up with a nice experiment to you're all in charge of please, and you should take advantage of that situation. So there actually have been some funny experiments that I've read about, and with knowledge of data science and statistics, you can kind of think about what they would have to do to test this. So here's one that I saw at some time. I read it in a book. That the question, the research question is: do people have the ability to sense when they're being watched, even if they can't see that person? So they actually, I don't know how they got that funded, but somebody ran that experiment. I'm sure if I wrote the grant for that, I would not get that funded. And I don't know how they walk around the department saying, this is my research, but somebody did that. But you can run that experiment, right? You face away from the door, and then stand behind in the open doorway, and see how many times your plebe can sense that they're being watched. So, Cadet Rice, let's try this out. So, Cadet Rice wants to test out whether his plebe can sense. He's got an extrasensory perception plebe. Sense when he's being spied on by checking how many times his plebe guessed when someone was watching him, even though the plebe couldn't see the person directly. Your plebe has eyes in the back of their head. Do they?
I hope not.
You can test this out. So to test this out, you're going to ask your plebe to face away from the door, and then you're going to go stand in that doorway 10 times and have the plebe record every time they sensed you were behind the door. Okay? If they got it right, you're going to give them a 1. If they didn't get it right, you're going to give them a 0. So there's issues with this, but let's just say this is the simplest thing you're going to do. Which of the following of these are a research question? Is it A? How many think it is A? Nobody's going to support you? You're here, you can just support someone, all right? Is a plebe going to be late for formation? Is that a research question? Sometimes.
It's not related to that. No.
We can give your plebe a name. Do you have 2 or 1?
Just 1.
All right.
Shark.
Okay, Shark is his name?
Yeah, Cadet Shark.
Okay. Can Shark sense when someone's watching him? Is that a research question? In fact, yes, that's the research question. Why is A not the research question? You're already getting into methods, right? Before you start, you have to have a research question started. And I told you this is a harder thing to do than it seems. We have, who plays football in here? Do you know Alex Herndon? Alex is one of my students that's doing a research problem. We have data. We have data from the sensors on helmets, and we have data on concussions. He now has to write up a research question. He hasn't done it yet because it's hard. He has 29 observations, and he's not sure what he's going to ask from that 29 observations, so he hasn't thought out a research question yet. So that's his task for our next meeting. It's harder than it seems, but here's the question we're asking. Can the plebe sense when someone's watching him? And in here, I've already started designing the experiment for that. That's doable. You have loads of time on your hands, so you can probably do this tonight.
Right now.
Which of the following is a parameter? How many? It's the same research. I mean, it's the same problem. By the way, I will tell you, I am named for St. Thomas, who was the doubter, and I don't believe in any of this stuff. But I'm always interested in the experiments they design, and the experiments they design for this kind of stuff is actually, they're really tightly designed because they know people like me are going to come and find flaws in it. So I was reading some psychology literature, and they're saying that these kind of studies are actually really, really well constructed because people doubt it. So I just find them intriguing. That's why I'm bringing them in here. I find it intriguing by itself that it's about study design and everything, but I also find it intriguing that somebody got it funded. So which of these are a parameter? Is it A, the percentage of times out of 10 that the plebe correctly identified? How many of you want to go with 10? with the A? No one? The long-standing percentage the plebe would correctly identify he was being watched? All right, the majority rules here, right? The number of times the plebe felt he was being watched. So it's 2. What's the difference between a parameter and a statistic?
Statistics only for like the amount of like observations you've recorded. So if you only have like 10, it'd be statistics would be out of 10, while the parameters, like if you set it to like infinity.
That's correct. So I'm going to actually summarize that in a second. That's important. So you don't want to get those messed up. And I say that's important because there's a class that's above this called 376, and they would all get that wrong. So this is my class, my product. You leave here, don't get that wrong. Parameter is a probability. If you flip a coin, it's got a probability of being a half. A statistic is if you flipped a coin 10 times and you looked at the percentage of heads you got. So which of these would be a statistic? Hope you were listening. Pay attention. JJ, which one of these?
A.
Pick one. I think it's A. You heard it, everybody else saying it? You
Oh,
go
I'm
with
using my
what?
resources. I think A.
Document your work. You could say?
Oh.
Anyone who want to challenge him? Everybody agree it's A? Okay, so that's it. It's this in your sample. It's the percentage that you're doing. So that 29% that we got, is that a parameter or a statistic? That's a statistic. I'm recording this, so this will be put online. And what I'm going to ask you is, like, the next time we meet, we actually have this as a quiz for grade, so that you know can you answer these things. So we'll keep drawing it back on looking back at these questions.
The same quiz now?
Some names might be changed to protect the innocent. Cadet Rice's name might be changed.
Sounds good.
Orders might be changed. The questions might be slightly changed, but the content is still the same. So just in summary, the difference between a parameter and a statistic is a parameter never changes. It's not a function of the sample that you obtain. For example, good definitions come from example. Like I have an example in my head, right? So an example is that the probability that you will land a head if you flip a coin is a half. That never changes unless you know something's altered on that coin. A statistic's dependent on the sample. The proportion of heads that you'll land if you flip a coin 10 times. You can you already have a sense of what's going on because you already told me that if I flip a coin 1,000 times, I'm more likely to get closer to a half, what the real distribution is. So you're going to see those things the more you do it. So there's a theorem that tells you that that's true, but you already sense it. Okay, what would it take to convince you that your plate has ESP? Superpowers.
That she has ESP?
Yes. What would it take? What if your plebe got it right 9 times out of 10? Would that convince you? You'd be shocked?
I wouldn't. My name's a weirdo.
Hey, you're being recorded.
I'm gonna show you for this video.
You're like, yeah, you're right. Like,
She's de-identified. What do you like? Let's suppose your plebe got it right 9 times out of 10.
maybe they guess every time. And just got one.
Okay, I think that's the problem. Right? They might guess every time. I think guess right 9.
I'd probably want to try it like multiple times, like different nights, different times a day, because like they might have just gotten lucky, like just like.
Your poor plebe.
I mean, it's mathematicians, you would take the R code, the R stuff, take 3 random chances, and then since 9 out of 10 would probably be larger, I would also test it again. But if you got over the 3 random chances, I would be convinced that since he's beating random chance, that he somehow knows someone's watching him.
Would you take just 9 times out of 10? Let's suppose they got it right 9 times out of 10. Would that be enough for you, or would you want to do it again? Just to
You
see
need 100 times.
Huh?
100 times for a good sample size.
Would that be considered hazing?
We're making him a better option.
So that was for discussion. So this comes up quite a bit. So in a lot of papers we have small sample sizes, especially some of the studies I work with, because doing stuff with humans is hard. And so you don't want to run things with humans, too many humans, because it's expensive. So the sample sizes get small, and then you think, well, maybe I have to replicate that experiment if I got something that is outstanding. For something like ESP, that's one that someone like me would say, your sample size is really small. You only did this 9 times out of 10. You know, I would like to see that again before I'm convinced. So what about this question? This is a little bit further in the reading, so if you haven't read it yet, that's fine. Take a guess. Alpha?
Yeah.
What's a null hypothesis then? How many votes we got for alpha? How about beta, B? One? What about 3? We got one for each one of these. So the null hypothesis is actually the second one.
Yeah.
So when so you have the steps for a research question, the steps for actually the research question and experimental design. When you're doing statistics, and we actually have research papers guiding people to do this, please write down what your null hypothesis is, what you think should happen, because if you're running some kind of intervention, you want to know that there was some change from what you think should happen. That's the null hypothesis. This is what I think should happen if I didn't do this, right? And people don't do that. So I'm writing a paper on dietary supplements right now, and it's on diabetes. And there's ways we measure diabetes in humans. And at the end of the day, they'll say, well, we checked all these things. We checked insulin levels. And we found that this dietary supplement affected this outcome. And it's not one of the main things that we think is the outcome. You know what my suspicion is? That they changed their hypothesis after they saw the data. Not supposed to do that. It's a big no-no. Alternative hypothesis. Take a guess. This is 1.2. Section 1.2.
Quick question.
Okay.
So null is just simply like what you think it could be.
Right. So think of the dietary supplement thing. You guys, I think a lot of cadets here take stuff for enhancing exercise, right? Diet supplements for. So if you think that works, you could actually run an experiment. So you have your null hypothesis would be that there's no effect. Everything's random chance, right? This is what if I want to say that that dietary supplement works, I want to test that out. My null hypothesis would be that there is no effect due to random chance, right? And the alternative hypothesis would be what? Think of the supplements. I don't know, what are you guys taking these days? Protein. Does it work? Does it make you a better physical performer? Which one of these would be the alternative hypothesis? C. That it can't be explained. So it's the opposite of whatever your null hypothesis was. So if you had protein enhances my ability to deadlift, then it would be, the alternative hypothesis would be that I'd be able to deadlift more if I took this protein shake, whatever you're taking.
What have you found in your research of?
There's no effect.
Would you say like on muscle gain though, like it does enhance your
There's a really nice study where they took everything from the body, like sweat and protein that's excreted from the urine, and there was no effect from bodybuilders.
So what you're saying is we want to get bigger with the steroids, huh?
You want to get bigger, you have to go down in Arvin in the morning, and I should see you there.
Yes.
But if you wait, so you're saying that even if you work out and take protein shakes, it doesn't have as like anything?
I don't think there's probably any difference in taking protein shakes or eating rice. You probably have to eat more though. That I've seen. That if you exercise, you're going to gain more lean if you eat more. Probably doesn't matter what you eat.
She's in the journey.
All right, what are the observational units?
The looks, the guess. The guess, right?
Yeah.
Because it's categorical.
It's a guess, the variable is whether or not they got it right.
That's correct. It's the rows of the Excel file that we just, what we just did with this, it's the preferences. In this case, it's the plebes' guesses, whatever you're recording at each row. Are you tired or are you confused?
I was confused. That was between the wording of A and B, and then I sort of got to the end.
So correct answer is observational units are the units that are filling in your rows in your Excel spreadsheet as you're recording this data. So if you're going to do this, some of you might do this.
So why would it be Cadet Rice? That's what confuses me. Because like, what are the
Oh, did I put his
observations?
name? No, in Cadet's Rice is his experiment.
He's testing it on his.
Oh, what? Okay, never mind.
Are you going to tell Shark he was famous today?
I'll keep that a secret. She can watch the recording if she wants to.
That's right. We've been calling her a he.
Is it? I have a question. First question. Is it categorical?
I'm going to ask you that. So variable. You haven't even talked about variables. Which one's a variable out of this?
Whether you got it right.
Which one you got? C?
No way, that's big.
B?
It's B.
It's the answer to the what you're recording as the call-ups, right? So it'd be that the plebe guessed it right or not. Is that variable going to be categorical, quantitative, or call it X?
C.
C. It's categorical because you're binning it. You either got it right or didn't get it right.
Is define by letter X just something random? Oh yeah, I was like, I haven't heard of that.
All right. You haven't seen this notation before, so have you seen this notation before?
In the textbook.
So this, I just wanted to decipher it. So when you see new notation, it takes people a long time to learn and get. There's a famous mathematician that said you don't learn math, you just get used to it. So you're just seeing it for the first time, so we'll keep kind of going back to this. This little H0 here, what it means, it's the null hypothesis. That's what that symbol means. And a research paper, any research paper that's using statistics should have that null hypothesis written down. And the pi, they're using pi, stands for probability. So this would be like a head-tail flip experiment. I don't know if you guys know MJ. He's not in 206, he's in 205.
You Michael Jackson?
Yeah.
That's her investment.
Cut my son's hair. We have a Michael Jackson, and we have Major Brian Adams. I don't think either one of them sings. But Michael Jackson cuts hair. Huh? Well, they know him as Major Adams or Sir. No, maybe not. Okay, so, and this one, you might not have seen this before, but when someone's supposed to list out their statistical process, they have to list out the null and the alternative hypothesis. This is one of the most missed questions in 376. And it's so fundamental. I didn't teach 206 before I taught it, and I was kind of scratching my head going, what did they learn in 206? Because like in 206, that's like fundamental. You have to write that down before you do any statistics. So the first one's correct. What is C, by the way? Ah! Quadratic formula. I thought I'd bring back good memories.
You did it. You use it in.
All right, what I want you to do now is, I'm tired of talking, so I kind of want you to think about what, this is, sometimes you need more than one time to think about something. So here's an example. Let's suppose that, so back up here I have this problem. MJ's flipping a coin, he thinks it's not fair, he thinks it's weighted on one side, so he plans to flip that coin 100 times, so he's going to find out that if it's unfair or not. What if he gets 60% heads, 70% heads? When will he be convinced that it's an unfair coin? So what I'd like you to do is pair up. Two of you pair up and then write your answers on the board and decide what the following answers are. If you have your book with you, look them up. I think the e-textbook can serve